All right, so when we're doing n times per year, compound interest, when we're going to accrue the interest more than once. Now, here's the interesting thing. Our APR is our annual percentage rate, the yearly interest. But when we're going to accrue it multiple times, we break it up depending on how many times per year we're going to do it. Usually it's monthly. Like most of the things that you're actually going to interact with are monthly, but sometimes it might be quarterly. That's what the second example has. It could be biannually or semi-annually would actually be the better word, twice a year. It technically could be daily. Daily gets ugly, like just because the number's big. But we use 365 usually for a year. Although some books say 360, it's weird. But so let's see what happens when we start doing compound interest compounded more than once a year. Ho, ho. So the difference is this n shows up in two positions. So one to break the interest into smaller pieces, but then the number of times we compound it, that exponent, is the number of years times the number of times per years. So even though our decimal is smaller, our exponent is much larger. So now that 5,000 times, we still have the 1 plus, now our APR is 3%, so 0.03 divided by monthly. So there are 12 months in a year. And then that crazy mess is raised to the 12 times 5 years. So that is going to grow to $5,800 and change. But that can also be, suppose you have $5,000 on your credit card and you have an APR of 3%. If you find that credit card, let me know. Most credit cards, the APR starts in the 20s. Bad ones are 30s or 40s. So even though it's only monthly, when you take 24 divided by 12, you get 3. Or 2, sorry. Yeah, don't know math. All right. So here, a little bit less interest, only compounded quarterly, and our deposit is less, but we're going to look at 10 years. So here, 12 times 5 was 60 compounding periods. Now let's see what happens. Now on any calculator, if you type exactly what I'm typing with the parentheses and the times, it will calculate for you. All right, so we're only depositing 3,000. And then we're going to do 1 plus our 2.5% is 0.025. And we're going to divide that. Quarterly is 4 times a year. And that is going to get raised to the 4 times the number of years, which is 10. So that is only 40 compounding periods. So let's see what we get. Yep. 3,849 and some change. So more money to start with, half the time, only a tiny bit higher APR, but being compounded monthly got us the same increase, number increase, as doing less money, slightly less amount, fewer times per year, but more years. So it's not the years so much as like the other little details. All right. Now, the other thing they will talk about in this section in ALEKS then is this annual percentage yield, sometimes called the effective yield or simply the yield, is the actual percentage by which a balance increases in 1 year. It is equal to the APR if interest is compounded annually. It is greater than the APR if interest is compounded more than once a year. So what you're going to do is figure out what happens in 1 year, and then we're going to look at what's the change as a proportion of the original, and that's how much we increased. If we multiply it by 100%, we'll get it as a percent. So if I wanted to know what is the yield on each of these accounts up here, I'm going to take what I had, the 5808.0839, then I'm going to subtract off the 5,000. So that is how much we increased, which we know is going to be the 808 point whatever. And then we're going to have that as a fraction over my starting value of 5,000. So that is 0.1616. If I multiply by 100, my effective yield is actually 16.16%. That is how much, basically that is the APR rate I would need in a compounded annually account to get the same impact as what we had here. Oh, no. I apologize. That was after 5 years. Rewind. We're going to go back in here, change that to 1. There we go. So 152.0798. I knew it seemed a bit much. So it's 3.04, a tiny bit more than the 3%. Yeah. If it had been 15% compounded monthly, that would have been the 16.16, because that would have been what we did in 1 year instead of 5. So you calculate the A for 1 and then do the difference over the original investment amount and convert it to a percent. So only gives us a 0.04 of a percent increase, but every little bit helps. All right, then we have some continuous and some random ones. So I'm going to pause it and then we'll finish all that in the last video.